In this doodlecast, I am going to go over type 1 versus type 2 error, and hopefully give you a visual that will help you understand it at a little bit of a deeper level. So, when we are looking at a type 1 error, I'm going to write it here, type 1. That's when we reject the null. So that is when we find significance. So remember, you can't avoid error. Either it's a type 1 error or it's a type 2 error. There is no avoiding it. You can decrease the probability of error, but you're not going to completely get rid of all error. So let's just say we are conducting an analysis, and here is our critical boundary. Okay, and this is when we're setting an alpha of 0.05. So that means that 5% of the probable data is in the tail. Okay, so is what it's saying is we're going to allow a 5% chance that our hypothesis will be shown to be significant just due to a fluke, due to random events that we're saying there's a 5% chance, because remember this converts to 5%, okay? So let's say that we have our at an alpha 0.05, our z-score, our z-critical value equals 1.96, okay? But that's not actually true, because if you notice, I'm using a one-tail test. And so we want to make sure that that's actually accurate when we look in our unit normal table. We want to make sure that we are accounting for all 5% being in that one tail. So when I look up 0.05, it's actually 1.64. So remember, it changes. So we automatically think, oh, 1.96, but that would be for a two-tail test. So we're actually looking at 1.64 because it's all in one tail. And in this case, I'm saying we're looking at an increase. So let's say my test statistic fell right here, okay? So that would be my z obtained, okay? And let's say it equals 1.71, okay? Well, in that case, we would reject the null because we say it's significant. That means more than likely I made a type 1 error, because it is what happened is I used 0.05, and that had an increased probability of it being significant just due to a fluke. Okay? So this is how I look at this visually. So now I'm going to look at a type 2 error. Okay? So with a type 2 error, and I'm going to put 2, that's when we retain the null. So we don't find significance. So let's say I am using alpha equals 0.01, which is a 1%. Oops. Let's see. So I'll say 1%. We're saying it's going to be only a 1% risk that we're taking that the test will be significant due to a fluke. So if you really look, there's only 1% of the data that's here. So it's less data compared to the larger, where we have 5% over in that large area. So 5% would cover all of this, where 1% only covers this little region over here, that tiny region. So let's say our test statistic fell right here where I said at 1.71. Okay, it's at 1.71. Well, if our alpha level was 0.01, that means we would retain the null. We would not find significance. More than likely because at 0.01, our test statistic didn't reach that far. So it fell before that critical boundary, which is right here. So at 0.01, let's look at what our critical boundary would be. Our z critical value for 0.01 is, let's see, 2.32. So 2.32. So our test statistic would have had to fall 2.32 standard deviations from the mean to have been significant. But it only fell 1.71 standard deviations from the mean. So it would be significant at 0.05, but it would not be significant at 0.01. So in this case, at 0.05, we're looking at a type 1 error because more than likely our test statistic was significant because our alpha level was not stringent enough, meaning it wasn't strong enough. It should have been maybe at 0.01 instead of 0.05. Then, if we had it at type 2 error, which is at alpha 0.01, that would have been a type 2 error. So type 2, just abbreviate. So a type 2 error. That would have been because at 0.01 maybe it was too stringent and we should have used a 0.05. Now, there are other alpha levels that we use in between, but right now you're just either using 0.05 or 0.01. So basically, let's clear up type 1 versus type 2 error. If you have further questions, please come and see me during my office hours. Go back. Have a type 1 error. I'm going to do this here. So I'm going to say right here is alpha 0.05 and this is alpha 0.01, okay? But if we have a critical value that falls right here, so that's our test statistic. So I'm going to put our obtained value, obtained test statistic. Doesn't matter what it is. That means in this case here, we have a type 2 error. But in this case, we have a type 1 error. Because right here, it's significant. So it's possible it was significant because we used 0.05. But right here, it's not significant. And it's possible it's not significant because we used 0.01 instead of 0.05. So no matter what, you're not going to get out of error. You just need to know when. So when you reject the null, it's a type 1 error. When you retain the null, it's a type 2 error. Now a type 3 error is a whole different ballpark. That is specifically if your test statistic fell over here and was significant. That would be a type 3. So if you hypothesized that there would be a significant increase in results, but you actually had a significant decrease in results, that would be a type 3 error. So that's just kind of a fluke that happens, but doesn't happen very often. So hopefully